Welcome to Tech Teach.
If we talk about the basic digital circuits, it can be categorized into two categories of the circuits. One is considered to be combinational circuits, another one is sequential. So if we talk about the combinational and sequential circuits, the basic definition that we have already gone through. So if it is a combinational circuit, any of the combinational circuit, then it will be having few inputs and there will be few outputs. It can be either one in output or more than one outputs can be possible. So here, in case of combinational circuits, whatever is the input, that will be responsible for the output. So the output here, so the output will depend on only the present inputs. Its meaning is at a particular time, if we are applying some inputs, with respect to that input only the output will be changing. So this is the combinational circuits. Next is the sequential circuits. So what is the sequential circuit? We will see. So in case of sequential circuit, the block diagram of sequential circuit, we can think of it. So there will be combinational circuit. So sequential circuit is made up of combinational circuit along with a memory element. So the output is received and stored into the memory element. So there is a memory element. So whatever is the output of the combination circuit, it will be stored into the memory element. Some output may be there. So this is the output. This is also a type of output, but it is stored into a memory element. And next time, whenever we are running this circuit, it will be the stored output will be behaving as an input here now. So there will be some inputs, that is for sure. There will be the inputs along with the basic or present input. There will be some inputs that will be depending on the past output. So there will be a past output. Based on that, the next output will be depending. So next output will be depending on the present input as well as the past output. So here, in case of sequential circuits, the output will depend on the present input as well as the past output. So I hope it is clear to everyone, and you might be already knowing this, like what is the basic difference between the combinational circuit and sequential circuit. So based on the input and output relation, we can say combinational circuit. In combinational circuits, the output is depending only on the present input, but in case of sequential circuits, the output will be depending on the present input as well as the past out. So based on the block diagram that we have just seen for combinational and sequential circuits, we can say, like in case of sequential circuit, here there is a memory element. So what we can say, in sequential circuit there is memory element. It may be having more than one memory elements also, or memory elements are there. But in case of combinational circuit, there is no memory concept. Though there is no memory element. We will just see what is the memory element in the coming slides. We will be looking at what is the memory element. But right now you can just see memory element is the device that basically stores few bits. It will be storing few bits. Okay, that will be behaving like a memory. So there is a memory element. So whatever are the past output, it is stored into the memory element and it is passed to the input side into the combinational circuit, and then there is a result, that is the output. So that is the sequential. So that we can conclude from here, there is no memory in combinational, but there is a memory in the sequential circuits. Further, we can say, in case of combinational circuit, if there is no memory, then also what we can say, if there is no memory, there is no feedback. Because what we can call it, like there is no feedback. There is no feedback from the output side to the input side. But in case of sequencer circuit, there is a feedback. There is a feedback from the output side to the input side. So this is going to see like the feedback. This is the feedback part. Next, we will see a few examples related to the combination circuits. So you might be knowing adder circuits, or subtractors, or multiplexers, mux and demux, and encoder and decoders. These are considered to be the combinational circuits. Similarly, in case of sequential circuits, the basic sequential circuits are considered to be the flip-flop, latches, then registers, counters. So these are the different circuits that are considered to be the sequential circuits. So I hope it is clear to everyone. In the sequential circuits, we will be looking at the circuits that are having few memory elements. So what is the basic memory element? We will just see. So the basic memory elements are considered to be the flip-flops. So we will be looking at the different types of flip-flops. Okay. So sequential circuits that we will be considering can be classified into two different categories. One is called synchronous sequential circuits, and then asynchronous sequential circuits. So synchronous sequential circuits, asynchronous sequential circuits is being categorized into synchronous and asynchronous. That is based on the timing, based on timing considerations. Okay, so if synchronous type of sequential circuits are there, in that case, all the memory elements that will be used into synchronous sequential circuits will be basically activated at the same time. All the memory components will be synchronized with each other. Okay, so we can say here in synchronous, it provide synchronization to all memory elements. All memory elements are connected with same clock, and these circuits are enabled, or we can call it like activated at a particular time. At a particular time, these synchronous circuits will be activated, and all the components of the synchronous sequence circuits will be connected with the same clock. Just opposite to that, if an asynchronous type of sequence circuit is there, then here all the elements that are connected with each other to form an asynchronous type of sequence circuit, they will not be having the synchronized. So here in asynchronous sequence circuits, all the memory elements will not be in synchronous with each other, or we can say like all the memory elements in asynchronous synchronous circuit will not be connected with the same clock. Its meaning is its circuit components are enabled or activated, enabled at any time. So at any time these components can be activated. It is not sure like all the components should be activated at the same time. One may be working in off mode, one may be working in on mode, likewise one is on, another one is off, likewise it will be working. That is asynchronous sequences. Basic memory element that is used in case of synchronous sequencer circuits are called the flip-flops. And here we can say the basic memory elements used in asynchronous sequential circuits are called like latches. So what is the basic difference between the flip-flop and latch? We can just uh, see here. In the latch, if we add clock to it, it becomes flip-flop. So this is the basic idea between latch and flip-flop. So latch is the basic memory element. So one latch will be, one latch is there, one latch will be storing one bit of information. Similarly, one flip-flop will be storing one bit of information. But into a latch, latch is the circuit that is not having the clock. And if latch is added with the clock, it becomes flip-flop. So what is the basic difference between latch and flip-flop? We will just take it here. The difference between latch and flip-flop and flip-flop. So we will just draw the block diagram. Okay. So it will be like if latch is there, It is a digital circuit, so there will be some inputs, and similarly there will be some output. But in latch, basically, it considers two different outputs. One is considered to be Q, another one is Q bar. Similarly, in flip flops, it is the flip flop. There will be some inputs. Along with these inputs, there will be a clock also. Clock will be as an input. Similarly, in flip flops, there will be inputs, and along with that, there will be clock. So it becomes a flip flop, and it will be having the output. So here also the output will be Q and Q bar. So here two different outputs will be there into flip flops as well as the latches. So flip flop and latches will be having two different outputs. One is Q, another one is Q bar. So Q and Q bar, in the sense, one will be the Q, then its complement is Q bar. So it will be generating two different outputs. One will be the uncomplemented form, another one will be complemented form. So these two are considered to be like the basic memory elements. Latches are very rarely used, yeah. So because latches don't have the clock, but once if we are using latches, whenever we are applying an input, it will be working. It will be working and it will be generating the output. But in flip flop, there is a clock. So clock tells this circuit, like whenever either high clock is there, low clock is there, or from low to high it is changing, then only it will be working. Otherwise, it is off, remaining in off mode. So whenever we are going to implement the circuits, either synchronous or asynchronous, we generally use the flip flops. So here in synchronous, flip flops will be used for sure, but in case of asynchronous also, latches are used along with the clock. So it becomes like the flip flops similar to that only. But in asynchronous, the latches will be used, but in case of synchronous, flip flops will be used. Because synchronization will be provided based on the clocks only, and clock facility is available into the flip flops only. So that's why flip flops will be used into the synchronous circuit. So we will just understand what is the basic difference between these two. So in case of latch and flip flops, latch is considered to be the level triggered. It is considered to be like, latches are considered to be level triggered, and flip flops are considered to be edge triggered. So what is the meaning of level triggered? So we will just see. So suppose there is an input. So there is an input. So input in digital circuits, inputs will be like a clock only. So it will be high and low likewise. So in case of latch, it is considered to be level triggered. So if it is level triggered, it could be like it is high level triggered or low level triggered. So what is the level here? So this is a low level, means it is represented by 0. This is the low level, 0. This is a low level, this is 0. Similarly, for a high level, you can say this is the high level. It is represented by 1. This is the high level, this is 1. So in case of latches, it is considered to be level triggered, in the sense, if whatever the input that we are providing, if it is level triggered, in the sense, if level is 0, so with respect to 0, whatever the condition will be there into the latch, output will be changing. Similarly, if it is high level triggered, so it will be triggering the change in the output based on the high level of the input. Okay, so it will changing the output with respect to either 0 or 1, high or low level of the input conditions. That is the level triggering. In case of edge triggering, so edge triggered is like this. There is the input. So here suppose a clock is there. This clock is there. So edge is basically decided based on, like, this is 0, this is 1, this is 0, this is 1, and this is 0. So edge. So this is the clock that is going from 0 to high. So 0 to high, clock is transitioning. So it is going from 0 to high. So this 0 to high This state is basically considered as the edge. This is the edge that is considered to be like the positive edge. And here from high to low it is going, it is considered to be the negative edge. So edge triggering is divided into two different types. One is positive edge or negative edge. Okay, so flip flops will be uh, activated based on, or it is basically working based on the edge triggering. Means the change in output of this flip flop will be based on either the positive edge triggering or negative edge triggering. In the sense, if it is positive edge triggering means whenever a positive edge will be coming, then only the change in output will be taking place into the flip flop. Otherwise, there will be no change in the output based on the input conditions. Okay. Similarly, if it is a negatively edge triggered, it will be considered as like whenever there is a negative edge coming, then only the output will be changing into the flip flops based on the input conditions. Otherwise, there will be no change in the output of the. In case of representations, the flip flops, if it is positive is triggered or negative is triggered, how it is represented in the block diagram form, we will just see. So suppose there is some inputs. One is JK flip flop basically. So for an example, suppose JK is there. So J and K are the two inputs. Along with that, there will be a clock. So if this is the clock, so this will be considered as positive edge triggered. Similarly, if it is a negative edge triggered, then this will be J and K, and it will be, there will be a bubble into the clock. So along with the bubble, the clock will be indicated, and the output will be Q and Q bar. So this is negative edge triggered flip flop. This arrow shaped structure basically indicate the edge. Okay, so edge triggering of the flip flop. So one is like latches without clock. So you can say here no clock is there, but here there will be a clock. So in case of here, there is a clock. This clock can be considered as a control line. Control in the sense, based on the control signals only the flip flop will be activated. So control signal. So this flip flop, there is a clock, or we can call control. So control in the sense, the flip flop will be controlled or activated by this control signal or clock signal. So here flip flops are considered to be, these flip flops are considered to be the bistable multi-vibrator. Bistable in the sense, there are two stable states. One is 0 and 1. These are the stable states of the flip flops. In the sense, if flip flop is either changing the output, then it will be going to either 0 or 1. It may be either 0 or 1. So two stable states are there. That's why it is bistable. Similar is here also, the latches is called the bistable multi-vibrator. Here also two states are there. It can be either 0 state or 1 state. So that's why it is considered to be the multi-vibrator, bistable multi-vibrator. So next, then we will be starting like first we have seen. So there is a latch, then there is a addition of clock, and then that becomes a flip flop. So we'll just introduce like what is the latch first. So basic latch circuit we will be looking at. So basically this latch can be of different types. Latch is having of like SR latch, JK, T latch and D latch likewise. Similarly, the flip flops are also, flip flops are divided into four different types because it is made up of latches only. So latch along with the clock it becomes flip flop. So SR latch, SR flip flop, JK flip flop, T flip flop and D flip flop. So in the syllabus we are having the flip flop. So we will be implementing the flip flops with the help of the latches. So with the help of latches, we will be indicating like how the flip flops can be implemented. These four types of flip flops. So first, we will be looking like what is the basic latch. So first latch that we will be looking is the SR latch. SR, any one of the latch we will be just looking like how it basically works. So SR latch, and also these latches so or any digital circuits in the module one we have seen, like whatever the digital circuits are there, these can be made up of universal gates. This can be made by using universal gates, NAND and NOR. Why? Because it requires less number of hardware, less number of transistors are required. Okay, so NAND and NOR we basically consider to be universal gate because these gates can be used to implement any of the digital circuit. So similar, the latches are considered to be the digital circuits or flip flops are digital circuits. So we can implement these digital circuits by using either NAND or NOR logic. So we will not be proceeding to consider both the cases, but yes, the basic understanding by using the NAND logic we will be looking at out. So SR latch by NAND gate, we will implement that. So a latch is basically like if two inverters are there connected back to back in a feedback path, it will be considered as a latch. This is a latch. Okay, this is the concept of basic latch. But once we are going to implement by SR latch, this same representation we can represent likewise also. There is a NOT gate and there is another NOT gate. The same circuit. This circuit is same as this one, but it is represented likewise. So this considered to be like inputs. Okay, so this is the input and this is the output. So likewise. So this is the basic latch. If we talk about the SR latch by using NAND gate, we can implement that. So SR latch is basically by using NAND gate, it is implemented likewise. So block diagram, above we have seen the block diagram already. So this is the block diagram of the latch, input and then two outputs. So how it is implemented? So this is the basic SR latch. So in the SR latch, two inputs are there. So what that input? It will be S and R. Two different inputs will be there, and output will be Q and Q bar. Two different outputs will be there. This is the basic SR latch by using the NAND gate. So a digital circuit is basically represented in terms of their truth table. So we will see what is the truth table of this SR latch. So into this truth table, we will see the input. So into the truth table, what we have the inputs. So S and R as the inputs, and then after input we are having the output. So output we are having this Q. So we can represent this Q only. Okay, or we can Q bar will be just opposite of the Q only. So we will be representing Q only. Okay, so into that we will be taking the conditions like it is 0 0, S and R are 0 0, 0 1, then 1 0, and then 1 1. So if we talk about here, so input is S is equals to 0, R is equals to 0. S is 0 and R is equals to 0. So first of all, it is a memory device. It stores bits. It is one latch, so one bit it will be storing. And you can just see there are two inputs. There is no clock. There is no input as a clock. So that meaning it is a latch. Okay, if it is a latch, it will be storing some data. So suppose initially it is having 0 stored in here. If it is storing 0 in the sense, Q should be 0. If Q is 0, Q bar should be 1. Okay, so if this is the case, so if this is storing 0, so this line is same, so this should be also 0. If it is 1, so this line should be 1 also. So now we will just verify that initially if we have stored 0 and 1, what could be the change in the output by putting S is equals to 0 and R is equals to 0. If both inputs are 0, then what is the effect on the output? Okay, so once we do the AND, because it is NAND, so AND and then NOT. So NAND is equivalent to and then there is a NOT. Same way, so we will doing the AND of it. So 0 and 1 is 0, not is 1, so it is coming out to be 1. Similarly 0 and 0, and is 0 and then not is 1. So you can just see, initially we are thinking of like it is having 0, okay, it is 0 and it is 1, but after applying 0 and 0, the output is coming out to be 1 1. So 1 1 it is coming out to be there, but this 1 1 it is not possible because q and q bar are complement to each other. So 1 and 0 or 0 or 1 should be there. So it should be complement. The output that is coming should be complement. It is not complement. Then we will change the condition. So instead of 0 1, we will be assuming 1 and 0 here. So if we are assuming 1 and 0, so if this 1 comes here, so 1 and here comes 0. So 0 0, after and it is 0 and then not it is 1. Again here 0 and 1 it is 0, and after not it is 1. So again it is coming out to be 1 and 1. Its meaning, for any value of q and q bar, if input s and r are 0 0, the output will not be a valid output, because valid output should be there, because it should be a valid output if one is q is 1, then q bar should be 0, or q and q bar should be complemented, but in both the cases it is coming out to be 1 1 only. Its meaning, if in the truth table we can just find it out, like if the input is 0 0, at that time the output will always be an invalid output. The output will be invalid. Invalid in the sense q and q bar both are coming out to be the same, that is 1. That's why it is an invalid output. So in case of SR latch, if we are putting 0 0 as an input, output will be coming out to be an invalid output. Next case we will be looking at 0 and 1. If S is 0 and R is 1, then if we are going to put the value Q is equals to 0, initially we are thinking like Q is 0 and then Q bar is 1. Then if we are applying input 0 and 1, then what will be the next output is like this is 0, so here it will be 0, this is 1, so it will be 1. So 1 and 0 and is 0 and then 1. 0 and 1 and is 1. So 0 and 1, that is 0 and is 0, then complement is 1. So again here you can see it is 1 and 1. So 1 and 1 is not a valid output. So we need to change the assumed value. So we have assumed 0 and 1. Now we will be assuming 1 and 0. Then we will be checking like what is the value. Value that is coming out to be should be valid output. So if we have taken assumed 1 and 0, so this 1 will be here, this 0 will be here. So 0 and 0 is 0 and then complement is 1. 1 and 1 and is 1 and then complement is 0. So you can say like there is a stable output. Stable output in the sense, if q and q bar is 1 and 0, the output is coming out to be 1 and 0. So if 0 is the s and r is 1, at that time the output, the q will be coming out to be 1. So here the output will be 1. Okay, I hope you have got the point. Next condition we will be looking. So this is 1 and 0. So S is 1, R is 0. And at that time, we are assuming again Q is initially 0 and then this is 1. If initially it is 0 and then it is 1, so this 0 will be coming here and this 1 will be coming here. So 1 and 1 will be 1 and then not is 0. 0 0 is coming out to be 0 and then not is 1. So first of all, both outputs are complement with each other. That means it may be a valid output. Okay, so output Q is coming out to be 0. So when S is 1, and R is 0, the output is coming out to be 0. Next case we will also check if we are changing it. So we are changing it with the input condition 1 and 0. In that case this 1 will come here, 0 will be coming here. So 0 and 1 and will be 0 and then this complement is 1. 0 and 1, 0 and then complement is 1. So you can just see here, this is coming out to be 1 and 1. So 1 and 1 cannot be possible because outputs should be complement. Both the outputs should be complement with each other. So it is not a valid output. Its meaning is like, its meaning the valid output was 0 itself. So when the q value is 0 and q bar is 1, at that time the output was coming out to be valid 1. So this will be the valid output. In 0 and 1 and 0 case, the valid output will be the 0. Next we will be considering is when both the inputs are 1 and 1. When both the inputs are 1 and 1. If both the inputs are 1 and 1, at that time we will be checking like if it is 0, it is 1. If it is 0, it is coming out to be 0. 1 is coming out to be here. So 1 and 1 will be 1 and then 0. 0 and 1, 0, and then not is 1. So its meaning is if it is 0, outputs are valid because it is 0 and this is 1. So valid outputs are there. Means input was 0, the initial q value was 0, then next value is also 0. Initial value was 0, 1, then next value is output value is again 1 only. So in 1 case, both the outputs are coming out to be same. Whatever is the previous value, the same value is the next value. Next, suppose we are changing it to 1 and this is 0. In that case, this is coming out to be 1, this is coming out to be 0. So 1 and 0, then complement is 1. 1 and 1 is 1, and then complement is 0. So you can say, so in this case, here also a valid output is there because both the outputs are complementing each other. So it is a valid output. So valid output, and also it is same as the previous output. Initially, we have assumed it is 1 and 0, and result is also 1 and 0. Its meaning, if 1 is the input, at that time, the output will be having no change. Whatever is the previous value, the same will be the next value. So we can say if 1 is the input, the q will be the previous value. Previous value it will be there. So previous value in the sense, if q if q was 0, if q was 0, the q n plus 1 is equals to 0. If q is 1, q n plus 1 will be 1. So this q is here is basically indicating the next value, q n plus 1. N plus 1 indicate like the next value or the next value. Q n is there in the sense we can say like it is the present value or the value that is just right now, and this what will be the value next, that is q n plus 1. SR latch is having this as the truth table. You can just see here there is no clock. So latch is having no clock, but flip flops are having clock. So now I hope you have got the idea about the latches. So we will just see what is the flip flop now. So based on the latch that we have just seen, we will be implementing the SR flip flop. The basic difference is one is having no clock, another one is having clock, and the remaining things will be the same. So if the remaining things are same, we will just thinking of the same way. So if we talk about the implementation, so SR flip flop by using NAND logic is, this was the input, okay, S and R. But now this will not be the S and R. It will be having a further NAND gate because we need to add the clock. So we need to add the clock, then two NAND gates will be used further to add the clock, and these two inputs will be clock combined together and it will be having like a clock, okay, and this is the S and this is R. So now this was the SR latch. In the SR latch we have added a clock. If we have added the clock, then it becomes an SR flip flop. This is SR flip flop by using NAND. Similar we can implement by using the NOR gate also. If we are using the SR latch or flip flop by using NOR gate, the output will be changing. Okay, the truth table will be changing. So we are basically considering only the NAND based implementation. So what will be the truth table? We will just check it out. So in the truth table, first input will be the clock also. So clock will be the one of the input. Then there will be S and R as the input, then q n plus 1. So q n plus 1 indicate the next value of the output, that is q. Okay, starting with the implementation, we will just see if it is clock is 0. At that time, if clock is 0, whatever is the inputs S and R, it becomes 0 itself. It has no effect on the output basically. So if it is, because based on the clock only, it is always 1 and 1. So output will be 1 and 1 here. Okay, so because this is 0, clock is 0. So if it is 0, it becomes like always it is 1 and 1. It becomes always 1. If it is 1 and 1, latch the latch is having 1 and 1. In that case, the previous value will be retained. So initially it is q is storing 0, so 0 will be remaining the same. So at the same time, we can say like if clock is 0 and inputs S and R is anything, if it is X is written, it indicate don't care. Don't care in the sense it is having 0 or 1. So it can be 0 or 1, then also it will not be having any effect. So if clock is 0, at that time, the next state will be the same as the next state will be the same as the previous state. So next state will be same as the previous state, that is qn. N plus 1 in the sense one time again, or we can say like suppose this is the clock. Suppose at this time the value is qn. Then after one clock cycle, at this point the value will be qn plus 1. After one time period of the previous value, what is the output, that is qn plus 1. After one more clock period, this output will be qn plus 2. One means from qn two times more, two clock cycle more. So after one clock cycle, what will be the output, that is qn, means the next output. This is considered to be the next. If this is the current output, then next output is this. So in that case, if clock is 0, at the time SR is anything, the output will be the previous output is that is qn. So qn will indicate the previous output. So if it is previous output, we say it like it is behaving like in memory move. It is a memory move, considered as the memory move. Okay. Next is if clock is 1, then only this inputs will be activated basically. So inputs will be activated when the clock is 1. So we will be considering 1, then it is 0 0 0 1 1 0 and 1 1 conditions. We will be checking it out. Clock is always 1. So at that time, S and R is 0 0. So if S and R is 0 0, means it is 0 0. So whatever is the output, it will be 1. Here also clock is 1 and R is 0. So here it is a 1. So if it is 1 and 1, so for 1 and 1, what is the SR latch? SR latch is previous value. So again here it is the case of 1, clock is 1 and S and R is 0 0. So again the output will be the previous value. So in that case, it is considered like it is working in hold mode. Means whatever is the output, the same value is being hold. The next one is if the S and R is 0 or 1, it is 0 and this is 1. If this is 0, output here will be 1. If it is 1, so 1 and clock is 1 always. Next 4 inputs, clock is 1. Say 1 and 1 is 1 and then not is 0. So here it is 1 and 0. So in the previous table, from because we have calculated it, so from the previous table we can just see this was the S. So S is 1 and then R is 0. S is 1, R is 0. S is 1, R is 0. At that time the output will be 0. So here output will be 0. So if output is 0, it is basically called reset. Reset. If we have done the reset, means whatever the initial value was there, that is the reset. 0. Next, if we consider the input is S and R is 1, 1 and 0. If this is 1, this will be 1 and this is 0 and this is 0, this is 1. So S is 0. So here S is 0, R is 1. So at that time output is 1. So here this output will be 1. This is called set mode. Similarly, we will be checking the next input combination. So for the next input combination, that is 1 and 1. So if we are providing this 1 and 1, so 1 and 1 is 1 and then it becomes 0. This is 1 and 1, it becomes not as 0. Means we have applied input 0 0. So if we are applying the input 0 and 0 into the above case, in the above case, you can just say if it is 0 0, it says it is an invalid output. So here also, in case of 1 and 1 into SR flip flop, the output will be the invalid output. This is called the reset, and this is called the set mode. So hold mode, set mode, and memory mode. Okay, so likewise is the condition. So this is the truth table of the SR flip flop. Same circuit that is there, SR flip flop, is basically combined together into a block diagram representation likewise. So this is the SR latch. So SR latch, so this will be the input. So this is S input and R input. The output will be Q and Q bar, and there will be a clock. This is the SR. Similar way, if we talk about the SR latch, this is S and R. There will be no clock. This is Q and this is Q bar. Next, we will be looking is with the help of SR flip flop, we will be implementing the JK flip flop. So basically, in case of implementation, so you can just see into the truth table. So in all other modes, that is okay. But when the S and R is 1 and 1, at that time, there is a invalid case. So we should be avoiding this use. But in terms of implementation, we can't avoid this. So that's why there is a requirement to have another flip flop. So to remove the invalid state of the SR flip flop, there is an implementation of JK flip flop. So how the JK flip flop is basically implemented, the same circuit is there. So this was the SR flip flop. So in the SR flip flop itself, if we are able to include one more input here, so this input is this Q bar, and here in feedback we are including, here is the Q. So this is the Q bar. This is now becomes J, and this becomes K, and it is Q. So the same circuit with little modification, we can obtain the JK flip flop. So this is the JK flip flop. So we will see what is the truth table of the JK flip flop. There will be a, then there is J and K inputs, and then the output, that is the next state. So initially we will taking the clock as 0, then J and K. Whatever is the J and K values are there. If we are putting K is equals to clock is equals to 0. So if clock is equals to 0, in the sense the flip flop is not activated, in the sense. Not activated in the sense whatever is the state that is available into Q and Q bar, it will be remaining the same. So output here in case of clock is 0 is considered to be the Qn. So this Qn indicates the memory state. It is having the storing the previous value. Okay. Then comes the clock. So if we are in having the clock is 1, then 4 different combinations will be there for J and K combinations. That is 0 0 0 1 1 0 1 1. Similar to that, if we get the output, so in case of 0 0 0 1 1 0 1 1, once we are going to put the values, you can get the output as, if it is 0 0, it will be the same as like Qn. So this Qn will be indicating the hold state. If it is 0 and 1, at that time the output will be 0 as the reset, and if it is 1 and 0, it is 1, that is set mode. And if it is 1 1, so in the 1 1 state, the change in the output, because we were basically interested in invalid state, output state becomes Q and bar. Q and bar in the sense whatever was the previous output, its complement will be there into the 1 1 condition. Once we put the value here, you can just verify it. So it is coming out to be Q and bar. This is called the toggle mode. The Q was initially 0. So after 1 1, J and K is 1 1, clock is high, then the output becomes complement of 0, that is 1. Similarly, complement of 1, that is 0. So outputs will be complemented, so that is called toggle mode. This is called the hold mode, similar to the SR flip flop. This is reset, and this is the set mode. So this is the truth table of the JK flip flop, and the circuit diagram is this. If we talk about the implementation by using the block diagram, you can just see by using the SR flip flop. If you think of, so SR flip flop is this SR flip flop, and there is a clock, there is a Q, and this is Q bar. So if we want to implement the JK, then we will be using an AND gate here, and one feedback is coming out to be here from Q bar, and this is Q, this is J, and this is K. Okay, so this is how the implementation of JK flip flop by using the SR flip flop can be done. And the block diagram of JK flip flop, we can draw it here. So two different inputs, one is J, another one is K, with a clock, and then there is two different outputs Q and Q. So this is the JK flip flop, and here it is. So by using SR flip flop, JK flip flop using SR flip flop. This is the block diagram of JK flip flop, and this is the JK flip flop using NAND gate. We are having two more flip flops. One is called the D flip flop. So what is the D flip flop? We will just use the JK. So JK, this is the JK block diagram. So in the JK flip flop, this is J, this is K, and this is the clock, and we are having Q and Q bar. So in JK flip flop, if we complement the inputs and connect with each other, it becomes D flip flop. It becomes D flip flop. So what is the truth table in case of D flip flop? Is, so here there will be a clock, and there will be a D input. Only one input is there, D, and output, that is Q n plus 1. So if this clock is 0 and D is whatever is the D, the previous value will be stored. If clock is 1, in that case, if D is 0, the output will be 0. If D is 1, the output will be 1. So D is also called the transparent. This is also called the transparent flip flop. Means if you are providing 0 input, output will be 0. If you are providing 1, output will be 1. This is the D flip flop. Similarly, there is another flip flop that is called the T flip flop. So by using the JK flip flop, we can implement the T flip flop also. These are very simple. So if we are having J and K, and there is a clock, so if we connect both the inputs of J and K together, it will be forming the T flip flop. T will be the input, single input, and the Q will be the output, and Q bar will be another output. So truth table here, For T flip flop will be, there will be a clock, there will be input T, and the output, that is Q n plus 1, that is next output basically. So if clock is 0 and T is anything, at that time the Q next state will be the same as the previous state, that is behaving like a memory. When clock is 1, in that case, and if T is 0 and T is 1, so if T is 0, it will be having the same value. So if T is here, so whatever is the T input, so if T input is 0, at that time the output that we will be having is the same value, that is Qn, that is the whole. If T is equals to 1, it will be doing the toggling. So here, if Qn is holding, it is called hold mode, and it is toggling, so it is called toggle mode. And this is the first mode, is basically the memory mode. That means when clock is not activated, then all the flip flops will be working in memory mode. So this is called reset mode, and this is called set mode. So sometimes it is asked like which flip flop is considered to be set and reset mode flip flop. So flip flop D flip flop is also called as set and reset mode. Set and reset mode flip flop. That is the D flip flop. Okay. So T flip flop is having hold and toggle mode. And you can just see, if we combine D and T, it is same as the JK flip flop truth table. So two parts of the JK means when J and K are both of 1 1, both are same. So both are same means when both are 0 or both are 1. This is hold mode. That is the same case into the T. T is having J and K same, connected with same. Both are connected together. So both are same. Then these two states are being considered into the T flip flop, and these two are in, based on the requirement, the J and K have been further divided into D and T flip flop based on the requirement. So different implementation of counters and synchronous circuits are there, so that basically requires toggling mode. So T flip flops are preferred. So whenever we are going for implementation where toggling mode is required, so JK is configured to work as a T flip flop. When the transparent mode means 0 and 1, whatever input is there, output is same. In that case, the JK flip flop is configured to work in the D flip flop. In the next class, we will be looking at is the characteristics equation, what is the excitation table for each flip flop.